So you're going to do two different experiments. First experiment is going to be about something called diffraction. And diffraction involves light bending around something. So what you're going to do is something called single slit diffraction. So in this, you're going to shine a laser through a tiny little slit. So that tiny little slit, we're going to call the width of that A. And what you're going to see when you shine this laser through this tiny little slit, it's going to form a pattern on a screen that's some distance. We'll call that distance capital D. Distance from the slit to the screen that you're going to form this image on. So your laser is going to bend when it hits this slit, and it's going to form a pattern. We're going to see a big bright spot, and then it's going to get dim, and then you're going to see a slightly less bright spot, and then a slightly less bright spot. So you're going to see this pattern. Okay? So you're getting something called diffraction, light bending around the slit. Now, there's an equation that lets you predict what this pattern is going to look like, and it depends on a few different things. We're going to get an equation, m times lambda equals a times sine of theta. And what you're going to do to get an idea of what this is actually looking like, we're going to take a line and draw it straight across to the middle of this bright spot. And then we're going to take another line and we're going to draw a line from the middle of this up to this first little trough. That part right here. So this is going to appear as a dark spot on your screen. And you're going to see all of this. So the shape that I've drawn here, even though I can't draw straight lines, this is a right triangle. So this angle right here is theta. This sine of theta is talking about this triangle up here. The wavelength is the wavelength of the laser light that you're using. And that wavelength is written on your lasers. I think, if I remember right, it's something like 650 nanometers or something. But check your laser, read it off of the laser. And then M is the last thing that we don't know. M is something called the order. So you're going to see a pattern, and it's going to be the same on either side. So you have m equals 1. This is called the first order. And this is finding a dark point in your pattern. There's one above and below. M equals 2 is the second dark spot. And the distance from this middle line up to the first dark spot, we'll call that y. We'll call that y1. Distance from that line to the second dark spot, we'll call that y2. I'm going to draw all this based on doing an experiment in the lab with the equipment we have. Okay, so this is diffraction. This is the important equation, and this is kind of the diagram. This is also drawn in your lab manual. Okay. Important thing to keep in mind for diffraction. Diffraction finds dark spots. And the orders that you have start at 1, 2, so on and so forth. So that's diffraction. And you'll read about that in the lab as you're going through it. Now, the other thing you can have is something called interference. Interference is going to look a lot like diffraction, because it is diffraction. But it's diffraction through two slits. And in interference, we define these slits according to how wide they are and according to how far apart they are. The distance between the slits we call little d. We still have the distance to the screen. That's large, or capital D. And then we also have a pattern in here. What we have in this is we have something called the diffraction envelope. So this is the single slit pattern. Same thing as a single slit. But then we see a pattern inside of this too. The pattern inside of this is interference. And it's much, much smaller. and you'll see it on either side. Maybe draw it in a different color. And this diagram is in your lab manual as well. When you have diffraction, or when you have interference, you have bright spots. So interference lets you find bright spots. And what those bright spots are places where the light from each one of these two slits is kind of, if you've anybody ever drop a rock in a pond or a pool, and see it ripple out? So that's what's happening here. You're seeing little ripples coming out from this. And places where the ripples combine give you bright spots. M equals 0, M equals 1, M equals 2. And you get bright spots. And then places where they cancel each other out, you get dark spots. The equation that describes this, exact same equation, m lambda equals d sine theta. So it's very similar physics. Okay? And what you're going to do in the lab is you're going to measure these quantities, and you're going to literally, I mean measure them. And you're going to literally see this happening on your screens. Okay? So these are the equations you're going to use, and then let's show you how to do the measurements. Yeah? Okay.
He's just recording over there. Oh, gotcha.
He wants to be on camera.
Yes, I'm just recording this for the evening lab too. So here's your lab setup. You have these little tracks. You have the laser right there, and then you have the slits and the screen. And then you're going to set them up according to what crew wants you to do. So what you do first is you've got your laser. Your laser has some switches, controls on the back of it. So there's a horizontal knob to adjust the position of the laser and a vertical knob to adjust the laser, and we'll see what that is useful for. And then sure enough, I was right. The wavelength of the laser is 650 nanometers. So wherever you see wavelength in your lab, that's the wavelength you're going to use. Okay, just convert that into meters. Okay, so you put your laser into this little optics bench, and I recommend lining it up so that the laser is at 0. Okay, so I put the laser at 0. Okay? Then what you want to do is
What did you do to change it to 0?
I made sure the laser slide it along here so that it's at 0 on this little scale. Then you take your screen, and you're going to stick your screen into the little optics bench. You can stick it in wherever. So I'll put it at, say, 50. So there, I've got my setup. I've got my laser. I've got my optics screen. And now what you're going to do is you're going to use the single slit set, and it says single slit set on it, for the diffraction, and then you're going to use the multiple slit set for the interference. Okay. And each one of these, as you rotate this around, it says what kind of aperture you have. So there's circular apertures, there's single slits, variable slits, and patterns. And you can see that on camera too. Okay. And you'll turn it to whatever single slit the lab tells you to. So let me turn it around to that. And you want to make sure that the laser is passing through whatever single slit you want to actually use. So we show you how that
Where on it
works.
is it past?
We'll see. So I'm gonna put this right in there, and I'm gonna set that to 20 centimeters. So now I can very quickly read off my distances, right? If I need to know the distance from the laser to the screen, 20. If I need to know the distance from the slit to the screen here, 50 minus 20, 30. Right, so I have all these measurements. And then what you're gonna do is you're gonna kind of have to turn off the lights a little bit so that you can actually see these. So crew is on the way to turn off the lights, and we'll see what we got. Yep. So there's a little switch on the back of the laser. You turn that little switch on, and what we need to do is get this so that the laser is shining through one of the slits. So we need to turn one light back on. We have a little bit of light in here. Do you still see the laser on the screen?
No, not really.
but we can see it right here. So see the single slits, and you can see the laser dot, and it's not actually going through the single slit. So if you get your eyes up really, really close to this circle, you can see if it's passing through. And if it's not, you can turn these little dials and knobs to move the laser around until it passes through the slits. And now do you see it passing through?
Yeah.
And you can see the pattern on the screen. Okay. So you might have to do that with the lights on, and then you'll turn all the lights off. So it's going to be an active lab with somebody turning lights on and off. You should get the Clapper Google light controls in there.
See your work.
I'll use Hey Krubel. Okay. So there, you can see you've got the laser passing through, and you can see even on the video, there's a pattern on this screen. So if you want to come around, you can see the pattern that you get.
You can see it through the screen.
You can see it on the screen too, yeah. So you can see bright spot, bright, dark. With diffraction, with a single slit, what you can predict with that equation are the dark spots. You are predicting where those dark spots are. So A lambda times, M lambda equals A sine theta. It's finding those dark spots. So M equals 1 is that first dark spot above it and first dark spot below it. M equals 2 is the second one, so on and so forth. Okay, so what you're gonna do is you're gonna draw those onto a sheet of paper. So you're gonna need to attach a sheet of paper to this screen so that you can draw this pattern. And then you're gonna make measurements off that pattern and use that to make some predictions. And then you're gonna follow the same procedure for a double slit. So when we put the double slit in, let's see if we are on a double slit. Instead of turning the lights back on, we'll use this wonderful physics invention flashlight and blind crew. Okay, so I can see there.
Where exactly are you seeing the slits? Like which?
So if you get up really, really close to this circle, see there's two little lines right next to each other, super, super small. So you have to get up really, really close on there, and then you can see the laser. And when I rotate that around, I can see the laser passing through those. And then when I turn off the flashlight, I can see this pattern again.
It's like smaller.
So what you see is bright line, dark line, bright line, dark line. But then you also can see, if you look really, really close, you can see a whole bright, and then it gets dimmer, kind of around here, and then it gets brighter and then dimmer. So you have two different bright and dark, bright and dim patterns. Sometimes it looks better when you rotate it around. You can see it's getting dimmer, and then it starts to get brighter again and then dimmer again. So you have interference and diffraction superimposed on each other. So you're gonna do the same thing where you put a sheet of paper here, mark these lines, mark these drawings, and make measurements off of that to make your predictions. Okay? So you're gonna use the two slits and the laser and the screen to do this lab. Any questions? Do you wanna ask any questions for the evening people?
No.
They had no questions, they want you to suffer.
Yeah.
Okay.
Do we measure it in centimeters? The distance between.
You'll wanna do all your measurements in the same units.
Okay.
So whatever you measure in, you wanna just convert so that everything is the same units.
Okay.
Said the dark voice. Very dark on the camera. Like the world's worst supervillain. Any other questions? No? Okay.
It's really